Alright, I just wanted to make a quick video explaining some problems that are in this pre-AP geometry test number 1 review. I'm sure there were some questions running around there, so I wanted to kind of clarify these before we got into test day. So questions 1 through 8 are all dealing with this diagram here. You need to be able to interpret diagrams. We should be fine with collinear and coplanar points. One question that I got was if point H is just on the outskirts or on the outside, on the border of this plane, does that still count? The answer is yes, but point H is in both planes, because remember, planes extend forever. So just because the diagram stops here, it still continues to go on. So yes, point H is actually in both planes. Same thing with point I. You should be comfortable with opposite rays, and then rays that are either coplanar or non-coplanar. 5, 6, and 7. I'm sorry, 5, 6, 7, and 8. Those are dealing with the intersection of geometric shapes. There are no questions on my test about the intersection of geometric figures, but it's a good thing to know. And again, you just need to be able to analyze and interpret these diagrams. So these questions are good to answer and be aware of. Below here, number 13 says name 12 different rays using this diagram. We should be comfortable with that. I mean, if you look at point C, you've got a bunch of rays coming out of that, but the ones that you can name, you could say ray CA, and then ray CE, and then ray CD, and then ray CB, and then you can go pick another point. So like point E, you have ray ED and ray EC, and so on and so forth. Do not add in lines. So an incorrect answer would be if you added and said, well, there exists a ray that starts at B and goes through D. I would agree that there exists one, but don't start adding segments and lines and diagrams. Just use what's here. There are at least 12 different rays. And then opposite rays comes in again, and then just naming lines. Make sure you're using the correct notation. So I'll just give a couple examples of a proper notation. So name a ray. There is ray. There's a notation for it. I'll make a better one. Sorry. Ray. CA. That's an example of an acceptable answer. Here's another one. Ray DE. And that is different from ray ED. Those two rays are completely different rays. And then I'll jump down to number 15. Remember, just an appropriate way to write the correct notation for a line. There is in that diagram, that's a symbol for line, a line with 2 arrowheads. So line AB, that contains C, point C. So you can find the other answers. I just want to remind you on appropriate notation. If we continue on to the next page, this is kind of where I want to camp out and spend most of the time. For questions 1 through 4, it tells us that angle 1 and angle 2 are complementary. So right there, you should be thinking a bunch of things in your head. If the two angles are complementary, then you know their measures sum up to be 90 degrees. So you can write off, well, if I know this, off to the side, you can write that the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. Then you continue reading. It says angle 2 and angle 3 are supplementary. So from there, you can write that the measure of angle 2 plus the measure of angle 3 equals 180 degrees. So you're going to use these two facts to help you solve this. So I'll do number 1 with you. They tell me that the measure of angle 1 is 80 degrees. Well, if I know that 1 and 2 are complementary, that means the measure of angle 1 plus the measure of angle 2 is equal to 90. So if I substitute 80 for the measure of angle 1, then 80 plus what equals 90. You got yourself an equation. Subtract 80 from both sides, and you get that the measure of angle 2 must be 10 degrees. Don't forget your units. When you're talking about measures of angles in this class, we're going to be talking about degrees. Then, knowing that the measure of angle 2, we're going to use that piece of information to help us figure out what the measure of angle 3 is. Well, I know that I know that angle 2 and angle 3 are supplementary. Therefore, the measure of angle 2 plus the measure of angle 3 is equal to 180. So take what you just solved for angle 2. The measure of angle 2 is equal to 10 degrees. Plug that into this equation here. So 10 degrees plus what equals 170. And there you go. You have a different, substitute 10 degrees for the measure of angle 2. So you have 10 degrees plus the measure of angle 3 equals 180. And so subtract 10 from both sides, and you'll get that the measure of angle 3 is equal to 170 degrees. That's how you answer those. 5, 6, and 7, these are, again, this another format, another way of conveying complementary and supplementary angles. Here on number 5, it shows that angle ABE is 90 degrees. That's a right angle, therefore we know its measure is 90 degrees. Well, angle EBD is a straight angle, so I know that this whole thing has got to be 180 degrees. Therefore, I know that the measure of angle ABD must equal 90 degrees. So if this guy is 90 degrees, then these two parts must add up to equal 90, and that's the equation you would write. You would say 2x plus 3x minus 10 is equal to 90 degrees. You got yourself an equation. Solve for x, and once you do that, so I've solved for x. So x is equal to 20. That's not what they ask for. They ask you to find the measure of angle ABC and find the measure of angle CBD. So you take what x is and plug it back in to those values. So when I plug x back into angle ABC, that means that the measure of angle ABC is 2 times x. So that's 2 times 20, so that is 40 degrees. And then when I take it and plug it back into the measurement of angle CBD, I can quickly find out what that angle measure is. 2 times x, so 3 times x. We know that x is 20, so 3 times 20 is 60, minus 10, that is 50 degrees. And that makes sense because we know that those two angles must add up to be 90 degrees. So 40 plus 50, that's 90 degrees. That's so we know that we did it right. It gives us confidence. On the next one, these two angles here, one being represented, or this measure is being represented by the expression of 5x minus 22, and this obtuse angle is being represented by the expression, or its measurement is 8x plus 46. Well, since these two angles are a linear pair, we know that they are supplementary. So that's the equation you would set up. The first angle, 5x minus 22, plus the second angle, 8x plus 46. When we add those two, we know we must get 180 degrees. So same thing. Same thing that we did for number 5. You're going to solve for x, plug x back into those expressions, and figure out what the measures actually are. Moving down 8 through 12, you're using this diagram. It says in exercises 8 through 12, use a diagram. Tell whether the angles are vertical angles, a linear pair, or neither. So you need to be able to identify vertical angles, linear pair, in any given diagram. Number 13, it's very similar to 5 through 7. They tell you that they're either supplementary or complementary, and you need to set up an equation to solve. So for number 13, it says the measure of one angle is, well, I don't know what that angle is called, but it really doesn't matter. I'm going to call it, it says the measure of some angle, I'm going to call it angle Z. It doesn't matter what I call it, just some angle. The measure of one angle, I called it angle Z, is 3 times the measure of its complement. So I'm going to say that its complement is angle A. Well, there's something else that I know about it. If this angle and the other one are each other's complements, then I know that the measure of angle Z plus the measure of angle A, that must equal 90 degrees. Because it said that they're complements of one another. So what you'd have to do is, over here, you have two unknowns. You have two variables, the measure of angle Z and the measure of angle A. That's not a good thing when you have one equation with two unknowns. But luckily, we know something else. We know that the measure of angle Z is 3 times the measure of angle A. So what you're going to do is take that and plug it into this one. So rather than having the measure of angle Z, you're going to have what it's equal to, 3 times the other angle, which I decided to call which I decided to call A, but its name doesn't really matter. So then I have 4 of these measurements of angle A is equal to 90 degrees, and you keep solving, divide by 4 on both sides. So the measurement of angle A, of one of these angles, is the decimal. It's going to be, and I have to do 22.5 degrees. And then if the measurement of angle Z is 3 times that, we're going to have to multiply that by 3. So that's going to be 67.5. So the measurement of angle Z is equal to that. And when you add these up, they will equal to 90 degrees, and that's a good thing because they are each other's complements. So for 14 and 15, you have to do a similar thing, kind of set up equations and solve for the angle measures. If we move on, you've got a bunch of these diagrams. You were only assigned 16, 18, and 20, but they're all very similar. Whenever you have this situation going on, 2 lines intersecting, there are always 4 angles being formed. So whenever you have 2 lines intersecting, you've got those 4 angles happening. And there's a bunch of angle relationships happening in this diagram. First off, you have vertical angles. And you should be familiar with vertical angles, and you should be able to identify them. In this case, you got angle 2 and angle 4. That's one set. And then you have angle 1 and angle 3. Well, what's true about vertical angles is that they are always congruent. If they're congruent, that means they have the same size, same shape. Therefore, their measures are equal. So you could take their measurements and set them equal to each other. In this diagram, you also have linear pair. And in this example, you have 4 linear pair. You got angle 1 and angle 2, angle 2 and angle 3, angle 3 and angle 4, angle 4 and angle 1.